Okay, we've been focusing on quadratics a lot. So we are going to now, instead of focusing on the graphs, start moving to focusing on the equations. And we are going to be looking at 3 different methods to solve quadratics. Today we are going to focus on 2 of them, and then in the next video we'll focus on the 3rd method. So the first method we've already seen, which is by graph. Okay, I have a problem here. It says a diver is jumping off the high dive. The function y equals negative x squared plus 6x plus 14 is represented below. When will the diver reach the water? Okay, so we are wanting to actually solve for a solution here, for an answer. And we know that we can look at a graph and find that. Okay, when will the diver reach the water? We need to figure out what key feature of our graph would help us determine that. So if he is jumping off the high dive, he will reach the water at a height of 0. So here would be the high dive. He'd jump up, back down. So when our height is 0, we have a solution, and that would be our x-intercept here. Okay, so in our equation, we're looking at when is our y, our height, 0. All right, so we can look at the graph and know, oh, we need to look at our x-intercept. That is a solution to our quadratic when our quadratic is equal to 0. Okay, I just want to go ahead and tell you now an x-intercept could be called a 0 because the y value is equal to 0. It also has the name root or roots. Okay, and if I say what are the solutions to the quadratic, I'm all talking about the same numbers. All right, in this case we only have 1, and it looks like it is approximately 8. Okay, the tricky thing about a graph though is unless it's on a perfect point, it's hard to tell what it is. So this one, I don't know if it's right at 8 or just before, and if it's just before, I don't know what the decimal is. So graphing is a handy visual tool, but it's actually not our most accurate tool, at least not by hand. All right, we would need technology to do that. So let's actually look at the second method, which is solved by factoring. We already know how to factor, and we've already seen this when we're looking at trying to find the x-intercepts from the standard form. Okay, so this is being more specific. Solved by factoring, here are the steps that we need. So if we have a quadratic trinomial, that's what we're going to focus on. We first have to make sure it's equal to 0. So we saw in the other one that equaling to 0 was finding an x-intercept, and that's what we're focusing on here. Okay? Always check for a GCF first, then you can factor the trinomial that's left, and then you can solve each factor for x. So I have 3 examples here. So let's do the first one. 2x squared plus 6x equals 0. So first we are equal to 0, and I'll talk about why that is so important in a minute. Okay? Now I need to check for a GCF. We have one here. 2x, so I'm going to divide by 2x, and that gives me 2x, and then in parentheses do your division. 2 divided by 2 is 1, and then x squared divided by x is just x. 6 divided by 2 is 3, and our x over x cancels out. Okay? Equal to 0. Now the reason it needs to be equal to 0 is something called the zero product property. Okay? So what that property says, if I have 2 things, so let's say I have a times b, and they both multiplied together equal 0, then what do I know about at least one of those things? Well, the only way to multiply to get 0 is to multiply by a 0. So that means either a was 0, multiplied to b, and that gave you 0, or b was 0, multiplied to a, and that resulted in 0 as well. So we have 2 possibilities. So we are turning our quadratic into 2 things being multiplied so we can apply that zero product property. Okay, but that only works if we're equal to 0. If we're equal to any other number, it doesn't work the same way. We can't use that property. So now we have 2 possibilities. Either our first factor, 2x, is equal to 0, and it makes the whole thing 0. Or our second factor, x plus 3, is equal to 0, and it makes the whole thing 0. Okay? And we've got a test for both of those. So all you do is you take each one, 2x. I want to know, what does x have to be in order to make 2x 0? So you can just solve the equation here. I would divide by 2, and I would get x equals 0. So one of my solutions is actually 0. Now I can try with the other one. X plus 3 equals 0. So thinking about this factor, what does x have to be in order to make this statement true? Okay, if you're not sure, you can solve the equation, minus 3, and I get x equals negative 3. So my two solutions are x equals 0 and x equals negative 3. Okay, since we're not talking specifically about a graph, we do not have to write these as coordinate points. We are actually talking about a solution to an equation, so x equals is fine. All right, let's try another one, just practicing, going through the steps here, okay? All right, 3x squared plus 12x equals 36. So our first step says it must equal 0, so we can use that zero product property. So all I need to do if it's not equal to 0 is subtract over the term. I combine it with any like terms, but 36 doesn't have a like term there, so I'm just going to put it on the other side as a negative 36. Okay, now I can look for a GCF. We actually do have one here, which is 3. So I'm going to divide everything by 3. Put the 3 out in front. And then 3x squared divided by 3 gives me x squared. 12x divided by 3 gives me 4x. 36 divided by 3, that would be a negative 12. Okay, and equals 0. So we can actually factor this again since it's still a quadratic trinomial. Okay, so I'm going to set up my two sets of parentheses here. X squared can split as x times x. Okay, now we need to see what multiplies to be negative 12. And then when we check our middle term, we get a 4. So multiplies to be negative 12. We've got 1 and 12, 2 and 6, 3 and 4. I need one positive and one negative in order to multiply to be negative 12. So this is just a reminder of factoring, which we've done this year already. Okay, and if I look here, I think this negative 2 and 6 will work. Let's give it a try. Okay, and then if I check my middle term, I would get an x times a 6, which is a 6x, and a negative 2 times x, which is a negative 2x, and that would give me positive 4x. Okay? So I have my factors here. I'm going to bring down that 3, and I'm still equal to 0. All right, now the next step says to solve each factor. Now if you notice here, this 3 is a factor. It's a GCF, a greatest common factor. But unlike this one, it doesn't have an x. So this one has a variable, it'll give you an answer. This one doesn't have a variable, it won't give you an answer. Because if I try to say what will make 3 0, there's nothing that will work to make that true. So I can just ignore that. Okay, and I want to focus on these two factors. What will make x minus 2 0? What will make x plus 6 0? And that will give me my two answers. So let's focus on this one. X minus 2 equals 0. What x value do you need to make that equal to 0? If you're not sure, solve your equation by doing inverse operation. So you do the opposite, and you should get it x equals 2. Okay, now let's focus on the second one. What would make the factor x plus 6 equal to 0? Very good. So you're going to subtract 6, and notice you're seeing these opposite signs that we talked about before. All right? So anytime you solve, you're doing the inverse operation, which then changes the sign. And those are your two answers. X equals 2, x equals negative 6. All right, I got one last one to practice our factoring here. Okay, are we equal to 0? Yes. Do we have a GCF? No. So we are going to go straight into the factoring. I'm going to set up my parentheses here. And this is going to split up as 2x and x. Don't forget about this type of factoring when you have that extra number there. I still need to multiply to be 6. 1 and 6, 2 and 3. Okay, so do I need my 1 and 6 or my 2 and 3? I need to multiply to get a 13. So remember how we did this, okay? It was 2 times this number plus a 1 times this number to give us that 13. So I'm going to write that sentence out, right? 2 times a number plus a 1 times a number had to equal my middle term, 13. Okay? So we can try this out. If I put a 1 here and a 6 here, that would be too small. I could try a 6 here and a 1 here. 2 times 6 gives me 12. That's very close to 13. Let's finish trying that out. Let's see, 2 times 6 plus, or 6 times a 1 would give me 6. 2 times 6 is 12. 1 times 1 is 1, and that gives me 13. I think we found our numbers. So this is 2 times 6, so when you put it back in, make sure you do 2 times 6, and then 1 times 1. All right, I'm going to delete the rest of this work here so that we can solve for our 2 factors. Because remember, our main goal is not factoring here. Our main goal is to find the solutions. Okay, so be very careful about the question. If I want you to factor, I'll say factor, which means you'd stop here. But if you have an equal sign and I say find the solutions, then I want you to actually solve for x. So just be careful here. We've been doing the opposite signs here. This one is a little bit more difficult. This one's equal to 0. It just has an extra step in it. So the same question still applies. What will make this first factor equal to 0? But if you notice, I have 2 numbers here. It's just a 2-step equation. So do the inverse, minus 1, then divide by 2. So I'm going to subtract 1. 2x equals negative 1, then divide by 2, and I get the answer, x equals negative 1/2. And fractions are okay. Okay? And then I can do this one here. What makes x plus 6 equal to 0? What would that solution be? Subtract your 6, and you would get x equals negative 6. Okay? Most of the time you are looking for 2 solutions, but it is possible to have just one or none, and we will explore that later.